this next video, we're going to talk about 11.2, which is odds. So if you have ever played games and you've dealt with the word odds, usually games are odds against an event. Some people think it's, in favor of, but the odds are actually always against. And the way we find that is the ratio of the probability that the event will fail to occur to the probability that the event will occur. So remember, a ratio is just a fraction. So to find the odds against, it's just the probability of obtaining failure to the probability of obtaining a success. You may also look at it as the odds against an event are the number of outcomes unfavorable to the event over the number of outcomes that are favorable to the event. So, for example, let's look at the odds against rolling a 4 on one roll of a fair die. So if you'll recall, when you have a fair die, there's 6 choices. You could either roll a 1, 2, 3, 4, 5, or a 6. So if I want to find the odds against rolling a 4, I'm looking at the probability of failure over the probability of success. So failure just refers to the probability I'm not going to roll a 4. So that's 1, 2, 3, 4, 5 out of 6. Over the probability of success. That's the probability I do roll a 4. Well, there's only one 4, so that's 1/6. If I divide 5/6 by 1/6, you can use a trick where you can cancel out the denominators. The 6's go away, and you're left with just 5/1. And the reason is you're really just dividing 5/6 by 1/6. Remember, when you divide, you skip, flip, multiply. So you skip over the 5/6, you flip the 1/6, and it's actually called the reciprocal. You turn it into 6/1, and then you multiply. So skip, flip, multiply. And 5 times 6 is 30, and 6 times 1 is 6. And if you reduce 30 over 6, you get 5, or 5/1. So that's a trick you can use. Just cancel out the denominators when they're the same like that, as I did in orange there, and you'll get the answer. So we usually write odds as not as a fraction, but using this notation, and we read that as 5/1. So it's a 5/1 odds against rolling a 4. And that makes sense. There's 5 numbers that are not 4, and then there's one that is. So the odds of not rolling a 4 are a lot stronger than the odds of rolling a 4 in favor of it. And we're going to look at that as well. Okay, pause the video, take a look at the circle graph, read the question, and then you can unpause when you're ready to find out how to answer. In a recent survey, students at Valencia College were asked to name the brand of blue jeans they preferred. The circle graph shows the results of the survey. If a student from the survey is selected at random, so again, that means everybody's got an equal chance of being chosen, determine the odds against the individual preferring, so letter A says preferring Levi's. So we're looking for the odds against. So remember, I want the probability then basically that it's not Levi's, right? That would be failure, over the probability that they do like Levi's. So what I need to do here is look at, okay, how many are Levi's? Well, I only see 35%, right? 35% just means 35 over 100. So my denominator is 35 over 100. So what's the probability of not preferring Levi's? If 35% prefer it, that just means that 100% minus 35% don't. And that gives us 65%. So 65 out of 100 would not prefer it. And again, I can cancel out the 100ths, and I'm left with 65 over 35, which we would write 65:35, which just means 65 to 35 people do not prefer Levi's. The odds against an individual preferring Wrangler, again, it's the probability of someone not preferring Wrangler over the probability that they do. So first thing I'm going to look at here is how many prefer Wrangler. I see 15%. So my denominator is 15 out of 100. What would my numerator be? So if 15 out of 100 prefer it, it's just 100 minus 15 that don't. So 85 out of 100 don't. And again, you can cancel out the 100s, and you're left with 85 over 15, which we would write as 85 colon 15. So it's an 85 to 15 odds against an individual preferring Wrangler. So now if we're looking at odds in favor, all we're basically doing is taking our fraction and just flipping it over. So now we're looking at the probability of success over the probability of failure. So think of it like this. Odds against an event are A to B. So odds in favor are just B to A. So if I went back to the example you just did and I said, determine the odds in favor of an individual preferring Levi's, it would be 35 to 65. And what are the odds in favor of an individual preferring Wrangler? It would be 15 to 85. So let's talk about cards again. Recall that we have a standard deck of playing cards, and that's 52 cards. You can always refer back to the information about cards if you want in 11.1. So I want to determine the following. First, we're going to determine the odds in favor of selecting a queen. Okay, so in favor of means I want success over failure. So the probability of success over the probability of failure. So what's the probability of selecting a queen? Well, there's 4 queens. There's the Queen of Hearts, the Queen of Clubs, the Queen of Spades, the Queen of Diamonds. So the probability would be 4 out of 52. Over, what's the probability of not selecting a queen? So if I have 52 cards and 4 of them are queens, all I have to do is subtract to find the number that aren't. So there's 48 cards that are not queens. So the odds in favor of selecting a queen would just be 4 over 48, which reduces to 1/12. And remember, we write that as 1 colon 12. So the odds are not good. What about the odds against selecting a queen? So now we're looking at against. So if you'll remember, that's just taking the fraction and now flipping it. So without doing any work, it's just 12 to 1. In this last part, we just discussed quickly trying to figure out odds in favor of an event without using probabilities. Okay, so how do we determine probabilities from odds? The odds against Carmen being admitted to the college of her choice are 9 to 2. Determine the probability that A, Carmen is admitted, and B, Carmen is not admitted. So now we're given odds and we have to work backwards to figure out the probability. So one of the things I'm going to focus on here is this 9 to 2. Think about what does that refer to? It's the odds against. So that would tell me then that my denominator would just have to be the success and the failure. So odds against, remember, means failure to success. So failure is my 9 and success is my 2. And if I add them together, I get 11. Okay, so that tells me that if I look at a ratio of failure to success, it's 9 over 11 and then over 2 over 11. Because remember, the 11s would just cancel, and that's how you would get the 9 to 2. So if I'm looking for the probability that Carmen is admitted, I would be looking at the odds in favor. So that means that I am looking at success, which is 2/11. So admitted is another way of saying success. And that's 2/11. So that's the probability that she's admitted. And not admitted would refer to failure here. And that would be my 9/11. And again, the reason I knew that is because it tells me the odds against Carmen being admitted, against is failure over success. So my failure is 9/11. My success is 2/11. That wraps up the end of 11.2. Please make sure you're working on the homework. If you have any questions, please reach out to me. And then the next video, we are skipping 11.3 and we're moving on to 11.4, which is tree diagrams. Enjoy the rest of your day, everyone.